I started just as a gamer, and I liked buying games that had a level editor included. And I launch into that level editor, try out the features that they had. I liked building worlds and exploring them, building historical timepieces type, building castles I could walk through, that kind of thing. I had done a lot of Lego building before having a computer. So it was a translation of that, physical, hands-on into world building in a level editor. But I'd quickly get frustrated with the limitations of the level editors. So I started to get into coding and building my own graphics applications. And I started off in high school, even with some ray tracing and some OpenGL. And then all throughout college, I kept that going, kept a few steps ahead of the curriculum in the graphics program. And so by the time I was graduating, I was building game engines. And so I got together with some friends who I knew from college. We started a company, and first game project, we just had 2 programmers and 1 artist full-time. And so I built all the graphics components of our first game. It was a 3D game, and so that involved figuring out the art pipeline with the artist and figuring out all of the architecture for our rendering and how that ties into a lot of the other programs and the design and the tools and the level editor. And when we successfully launched that game, rebuilt everything with more know-how for another project. And so coming to Double Fine, I already understood a lot of how an engine can work from the ground up, but seeing how a more mature code base operates was an interesting experience, and how much was coincidentally in common with how I had built something on my own, and then also what sorts of insights the experience of a lot of the programmers here brought to it.
Now, why go through all the trouble to build so much stuff yourself instead of just using something like out of a box that already pre-existed?
Right. Well, I think more than people realize, games are flavored by the tools that are used. So I think it's important for companies to put as much engineering effort as they can into custom tools, because it really helps differentiate a game. There's certainly some periods where you could clearly see maybe an Unreal Engine 3 game and how the shaders operated on it, and the capabilities of the engine. And so with an in-house engine, your game isn't going to look like the other games on the market. You'll have certain strengths and weaknesses, but you can focus those on what your team is good at. So if, like at Double Fine, the team is good at creating characters, and you want them to be expressive and well animated. So a lot of the tools here are focused around that sort of character presentation. Where I was working previously, it was quite the opposite. Our strength was generally in environment building, so a lot of the tools reflected that. And there's a very strong level editor, and we ended up leaning a lot more on procedural animation and things like that in order to get walk cycles working right and things like that. So engineering can help balance the abilities of the artists in order to get the game delivered, but it can also reinforce the core strengths of the artists. When I'm tool building, I watch the artists work very closely so that I can see maybe the steps that after they add some content to the game, if it takes a long time for the game to respond and for them to get the feedback about how their art is working in the game, I know that's an area I need to optimize. And it's really about making their workflow feel kind of like interacting with a game. It should be a satisfying experience. It should be something that when they have expectations about how the tool operates, that it works within those expectations, and that it works quickly and responds quickly to those changes. And so part of it is like always working with real-time lighting. I've worked with engines that produce before as a programmer that produced beautiful light maps. And those light maps, however, would take maybe an hour to bake. And so the separation between moving a light and seeing that result was so long that, that I quickly get frustrated with it. And so I understand where an artist is coming from when they're working with a tool and they make that change and then they have to wait for the result. So I've always emphasized real-time lighting. And so from the graphics programming standpoint, real-time lighting is generally going to be more expensive. But that's okay if you can introduce it to an artist in the context where maybe they can't use 100 lights anymore, but the 10 lights that they have very fine control over, and they can make those 10 lights more expressive if they see the results of moving that light in real time than if they had, you know, an unlimited number of lights that would take an hour to bake. So it always comes with trade-offs, but it's about finding those trade-offs that are going to make the game more expressive and are going to allow the artist to feel that they can put when an artist is creating the game, that the results match closer to what's in their head. And the virtual world has all sorts of its own unusual behavior. And if an artist is moving a light and they see some unexpected result, then if it took them minutes to see that result, then they'll be frustrated because now they have to correct for it and that'll take another few more minutes. But if the results are immediate, then not only are they not frustrated with the result, but now they incorporate it into their expectations for how the tool responds. So any little quirk or peculiarity of the rendering system then just becomes something that they can easily maneuver around and possibly even incorporate into something later when they feel free to explore and experiment with the tools. I mean, there's certainly a lot of happy accidents that can happen at a faster rate if people are able to interact with the game world, in a playful manner.
Did you have any kind of an art background to be able to sort of understand what it is an artist is trying to do, or maybe create tools that utilize their skills? Right.
So not really. I guess I could have started as a very poor artist. When I was working with other game engines, I'd create my own textures, do what I could to create some models without having a modeling application like Maya. But I understood the pipeline. And I think that was what was most important, is even though I didn't have any formal training in art and I didn't invest the time to improve my art skills, I understood what it took to take an art asset and then see it through until it's in the game. And so then when working from the graphics standpoint, I can create stand-in art, but I can also follow those steps and reduce the time from creating the asset to seeing it in game. And then also, when I look over an artist's shoulder, I understand the process that they're doing. It's just they're bringing a level of creativity to it and experience that I don't. So I like to reinforce their creativity with the technical ability. But part of what takes planning ahead is designing the tools so that the interface to them is it reinforces the design of the game. So different projects have different needs for how maybe a level would be edited. So if you're doing a game that's based outside, you want your terrain tools and placing down things like trees to be very quick and responsive. Whereas if you're doing something inside, you may want the tools to have a camera that can move through corridors very well. And so I'll focus my energy on how those tools work within the environment that the game needs. If an artist is performing an operation repeatedly, then if the tool can recognize that, that they're doing that and crunch those mini operations down into a single click, that's another kind of just process optimization that, that I'm always looking out for. If I'm sitting at my desk and I hear an artist over there click, 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 Diablo style, then it probably means that there's something I overlooked where I could give them a, if they're clicking rapidly to place trees, you give them a brush instead that they sweep and it spawns a bunch of trees. That sort of improvement means that they're not spending their time thinking and working on producing something that's very easy to understand. So, kind of boiling that level creation down into more, what are the creative actions involved with it, not just the mechanical process, because the machine is what's good at doing a mechanical process, and it should handle as much of that as possible, leaving the originality to the artist.
Now, since you came from an independent background and you built so many of your things on your own, what was it like coming to Double Fine and having these pre-existing systems that have been around since like Brutal Legend and have been iterated on and iterated on? It's like a very complex, large, versatile engine. Mm-hmm. So what was the process of adapting the things that you already knew and sort of getting some of your ideas up and running in that framework?
Yeah, so when I started at Double Fine, I was able to quickly find a good niche in shader writing because very few projects have as much, no project has as much shader code as it does game code. Mm-hmm. And so I was able to quickly understand the shaders that were being used in the Buddha engine for Massive Chalice, and then make the appropriate changes to that and kind of hit the ground running. And as I was making shader changes, I was also learning and absorbing the rest of the engine and how the different parts connected. So by the time I needed to make code changes, architectural changes to the rendering, I was pretty familiar with how it fit in. And then also coincidentally, the architecture was pretty similar to what I had kind of independently created. I think part of it, is just that those are maybe some of the natural conclusions that one reaches as a graphics programmer, for these are good practices for how to do things. Mm-hmm. And then some of it is, reading from common resources and, just general community knowledge about graphics programming.
Did you know that as you were interviewing, or was it sort of just a happy coincidence that you could start the job and like, oh, I have some familiarity with this
stuff?
I
had no idea what to expect. I had never worked in a company with other programmers who had prior experience with games. Mm-hmm. And so, yeah, I knew that I would be able to join the project with an understanding of what the goals of the project were, because I had already backed Massive Chalice on Kickstarter, mm-hmm. and so I had kept up with what they had publicly released about the lore of the world and the design functionality, and I was excited to play it. And so that being the first project that I worked on at Double Fine, it meant I didn't need anybody to brush me up on what the nature of the project was. I had just as any fan following a project does, I already had some ideas of how I might be able to contribute certain things, and just being able to actually drop into a project and immediately start making some of those changes and bringing some new ideas into it. That was very cool.
What were some of the things that, like, when you came on, were your highest priorities in terms of improvements? And were there suggestions from Brad and the rest of the team, or were you just sort of allowed to look at what was there and try to improve it on your own?
So there were definitely some areas of the game that were in flux at the time that I joined, namely the Fog of War. And there were some ideas circulating about whether it should appear map-like with kind of this canvas, or if it should be more misty and foggy, or really anything. And so I was more asked, to just experiment and try a few different things. And I had some experience with ray marching, and that's technology that works really well with misty type areas. So I implemented a fog of war algorithm that incorporated that, and also kept some of the, I thought what was cool and unique about the fog of war in Massive Chalice, that it usually is only a few feet tall, so you can see features of the level from a greater distance than you can, see the ground tiles and enemies. So I kept that low fog height, but was able to add in some noise and motion and shadows that made it feel like a thick fog that could obscure or very describe to the player, make it very clear from the design standpoint that they need to go explore that area. And that ended up working out really well. And I was able to carry some of the work that I did on that onto the corruption shader, which right now is incorporated when some of the enemies explode and they leave kind of this corrosive slime behind that can damage the player. Again, there was no art direction at the time for what that was exactly. There were, a few paint overs that varied wildly. And so I was able to kind of choose the one that I thought I could capture best and add a little bit of my own. I ended up incorporating it. It looks almost like a combination between frost and slime, and it has an animated effect. And once it was in, Brad liked it, and so kept on going. And that was familiar territory, working without very much direction. At an independent studio, there was nobody who had a who could tell you what it is that they wanted. So for every single element of the game, it had to just be created to fit those needs, and you put as much creativity as you can into it, and but you have to just get that done and get moving on to the next thing. And so seeing that process in common here, because the teams are much smaller than I think I expected, and mostly it's because Double Fine is just simultaneously doing so many different things, and projects will get large, during latent production, but mid and early production, it's structured very similarly to an independent team. Everybody can bring their own creativity to the table, and you don't necessarily rely on a project lead to make all the decisions, and instead you want everybody to be bringing interesting things in, and then seeing how they react with what everybody else has brought in, and then you can make that decision about what to keep and what to improve. Okay, so here I've launched into the game, and I'm going to explain a little bit about how the fog of war algorithm works, and how it uses a shader to get the volumetric appearance that we have here. So we can see that the trees are casting shadows into the fog. If I rotate the camera, you can see that the shadows in the fog are volumetric, and so I'll explain a little bit about how that works. So this uses a method called ray marching, which basically means that we calculate the fog for each pixel in multiple passes, so that we can get what the fog density is for many layers down into the fog. So if I can dynamically drop the number of layers down to here we just have one layer, and so if I rotate in particular, you can see that we just have one layer of fog here, and although it represents the coverage, it doesn't give you the sense that this is real fog, and it certainly breaks down in places where it's hovering over the ground. So by increasing the number of slices, here we go, we've introduced shadows as well. We can see that now there's an upper slice and a lower slice, and we're getting a little bit better a sense of objects being nested in the fog, and how their shadows change spatially as they cast into it. And I can increase the samples further. You can see that the more samples we get, the more of we get this volumetric type feeling, and we can really see how the shadows cut through it, and how the fog then begins to wrap and more cover the spaces that it's in. If I bump those samples all the way up, we can see it pretty much melts away into this nice soupy fog, and as the player goes out and starts to explore it, it feels more present in the world. Yeah, so the shadows are just calculated all the way down, and the soft interaction of the shadows with the fog is more just emergent based off of the number of samples that we use. So that the shadows are very sharp when we have few samples, and the more samples we have, it just softens that edge. There's another trick I'm employing here, where if I lower the number of samples to just a few, we can see this streaky appearance that happens because we can see each layer of the shadows. But I can add an offset per pixel that randomizes that and turns that more into a noisy space. And with just a few samples, that noise is pretty distracting. But when I raise the samples, the noise fades out. You can barely see it anymore. And if I get rid of the noise, we get these stripy appearances stripy appearance that can sometimes happen at certain shadow margins. And so by having both noise and a high number of samples, we don't get stripes, and it emulates what more samples would create, because that random offset also blurs after calculating the result. And so I'm making these real-time edits to the number of samples and the intensity of the noise, all right here with a MIDI controller. So I'm just using the Windows MIDI API and piping those values of these sliders directly into shader variables. So I'll go to the shader and show you both how the algorithm works and how I'm reading some of those variables. So here I'm calculating the fog of war for a given world position. And so all I need to do is some math here, reading some of the variables that artists had configured for the height of the fog of war, to figure out where the top of it is. I can also use the camera position as it moves around to figure out where, for a given world position, a ray drawn from the camera to that world position would first intersect the fog, and then also at the bottom where it would hit the ground. And when I know those distances, I can now march through it, just have a simple loop here through the number of samples. That will escape when I've calculated all the samples, or if the world position is higher than the march position, which basically means that I've run into an object. So I don't want to keep calculating fog behind an object. And so really the simplicity of ray marching is that, so here's the fog calculation, including a shadow calculation, and then I just increment the march. And this code that I've just demonstrated here constitutes most of the important characteristics of ray marching. It's a very simple algorithm, and the complexity and the strength of it comes out of that it loops. So that looping also introduces some, it makes it somewhat expensive despite its simplicity. And so I also calculated at a reduced screen resolution. So by calculating it at a lower resolution and then stretching it back up to fit the screen, I can run this loop many times without dragging down the frame rate. The other thing I can do here is, so up here we grab the number of samples that we need right away. And here we see some of the MIDI magic that I'm using here. I have a variable that's get passed into here, and this corresponds to one of the sliders that I'm using. So this .y means that it's the second slider, x is the first slider. And so if I grab that variable and I want to put that variable somewhere else, so here's where we get our shadow contribution. And so we can see that this shadow is calculated here, and then it's multiplied here into the fog. So if I change this to be, if I, what I probably actually want to do, so if I use the variable here, it would just darken the shadow. So what I probably want to actually do is use a lerp. And lerps are very common and useful. And what a lerp does is it's a linear interpolation. So it basically says take the first value and the second value and choose between them based off of the intensity of this third value. So if the third value is 0, we'll use the first value completely. If the third value is 1, we'll use the second value completely. And if it's anywhere between 0 and 1, we'll mix them together. So if it was 1/2, we would actually take the average of the two values. So by using a slider as a lerp here, I can fade between having the naturally calculated shadow and just using 1 here, which would be unshadowed. So I'm going to go ahead and leave that, and I can recompile the shaders. And I actually still have the game running in the background because we hot reload our shaders. And so what hot reloading means is that I can get the game into a state where I'm looking at what I'm working on and recompile the shaders. And then when I return to the game, I'm still at the same camera position. And so I don't have to play through the game. I'm going to compile a couple of shaders here just to make sure that these effects have gone through. OK, those shaders have compiled. I reopen the game. I reset these. And we see we don't actually have any shadows because the original slider value was 1. And I can fade those shadows in and out and see what contribution they're making to the overall scene appearance. So we see like up here where we have a nice shadow margin, I can just fade between those shadows. And I, again, just assign that to a slider value. And this relates in a bit to what I was describing with artist turnaround time. If I didn't have the sliders and all I could do was change shader logic in order to see changes made to the shader, then it takes about a minute to turn that around. If I have a very short shader, it might compile in a span of a few seconds. But even if the shader compiles in a few seconds, the number of varieties of that shader that I can see is constrained by that shader compiler time. With the slider, I can see hundreds of variations of the shader, particularly if I change these sampling patterns. I don't have to guess what happens if I drop the number of samples to 0. I see what happens here. And I can see maybe how many samples it is before the shadow's satisfactory and how many samples I need when the shadow is much more accurate. And so I can also extract those values and maybe use them as different graphical presets. All those things become possible now, and I can explore them very quickly. By having those variables that are predefined and mapping them into something that I can change in real time. Right. Well, we have so much computational power now that we could put all of that just into making the game prettier. But you get diminishing returns on that. And if you think about what spending 20% of the performance horsepower of the machine you're running the game on making it more real time and having more hooks in with the tools, that might be difficult to optimize, but if they're in the game during its development and it increases an artist's workflow from, again, several minutes into several seconds, that's a couple orders of magnitude of faster workflow to an artist. So it's well worth spending the 20% performance hit that you might get from that. that you might sacrifice your polygon count or some of the extra complexity of the shaders. If you put that into the tools instead, you're going to get a drastically better game.
You haven't had like a ton of time. I mean, you've been working on this for pretty much your entire life. It's been sort of like your passion to be doing these things, but you haven't had a tremendous amount of time in the industry. Double Fine is your first job since your independent job, right?
Right.
For people that are trying to get into the industry, just like some things that you found to be extremely helpful and just, helping you survive as an independent and then helping you find a job at a studio, and just sort of the best practices or the most constructive things you've done for your career.
Right. Well, one of the great things about game development is that nobody can tell you you can't do it. The tools are available, there's free tools, and as long as you have a computer, you can develop games. And it'll take a while before you have the experience to develop really great games. But if that's what you want to do, you should get started right away. I mean, with graphics, I started in high school. I didn't have a computers class. I didn't have any mentor or anybody who could demonstrate to me how the graphics that I was starting to work on operated. So I'd go online, I'd find resources, I'd find, there's freely available college course notes. All these things are out there and you can find them. You can, again, like starting out with level editors that are freely available if you want to do level design. If you want to do game design and you're not a programmer, board games are a great way to get into it because you learn about a lot of those trade-offs of resources and how a player's expectations work against what the game is presenting to them. And when you find harmony with those, how people, that separation melts away and people start having fun. If you're an artist, you can do the digital painting. You can. There are free modeling tools, and there's now quite a few lower cost or free versions of the more expensive tools. And although the licenses of those might not mean that you could release those games quite yet, you can improve your skills on your own. So nobody should wait until they have a job to get the training to do game development. If that's where you want to be, and if you want to be one of the best at doing it, just start. Just begin doing it. Find out how you can do it with the resources that you have, and find other people who want to do it as well. And as you're learning, as they're learning, put it all together. I mean, my first job as in an independent company, it wasn't an established company that nobody expected us to even be able to make our first game, but we believed that we could do it. And so we came together and, our artist exported his first model into a game engine. And, I wrote my first level editor, and we wrote our first networking. It was a multiplayer game, and it was really just about, again, pulling those resources offline, thinking really hard about the problem, and taking what's initially a lot of your free time, understanding that it can start as a hobby and build into a full-time job.